This video is meant for Faraday's first law of electrolysis. We are going to look at the first law alone, and in my second video we are going to look at the Faraday's second law of electrolysis. In the first place, let's look at this electrolytic cell. We have the cathode. Remember, cathode is connected to the negative terminal. We have the anode. Anode is connected to the positive terminal of the battery. Alright. The cations, we accept electron here. We accept electron here to become deposited as a metal. For instance, if cation is represented by M, 2 plus, it will gain 2 electrons and it will be deposited as M solid. Alright, so here, cation is deposited here. This is called cathode and it is connected to the negative terminal. Now, if you look at this table, if your cation is always 2 plus, then the charge on that cation will be 2. For aluminium, it will be 3. Aluminium will be 3 like this. That is aluminium. For silver is this, and we have silver solid. For oxygen is 4OH negative. Or okay, this is negative. I'm talking about cation alone. Alright? So, but let us have it in mind that oxygen, we have the charge to be 4 because it requires only 4 electrons to become deposited as oxygen gas. Alright? So, according to the first law of electrolysis, it states that the mass of substance deposited at the cathode is directly proportional to the quantity of charge passed through the electrolyte. Okay? Now, the charge that is passed through the electrolyte for only 1 electron is given as 1 Faraday. Let Q be the charge passed through the electrolyte. For 1 electron, 1 mole of electron, that is 1 mole of electron, we are told that that charge will be equal to 1 Faraday. Let me come again. The charge required for 1 electron, 1 mole of electron is given to be 1 Faraday. And we are told that 1 Faraday is equal to 96,500 coulomb, unless otherwise stated. Your 1 Faraday is always 96,500 coulomb, especially for exam like JAMB, WASSCE, NECO, etc. Okay? Now, from this we can generalize a formula. For n moles of electrons, Q is equal to NCF. Q is equal to NCF. N is the number of moles. C is the charge. On the cation. Is the charge on the what? Cation. And F is called Faraday. As a result of this formula can be used to solve few questions, and we must take it serious. Note the difference between DC and DC. This one is talking about charge while this one is a unit of quantity of charge, which is known as coulomb. All right. Now, we said first law states that the mass of substance deposited is directly proportional to the quantity of charge passed through the electrolyte. From this law, mass M is directly proportional to the quantity of charge. So as a result of that, mass is equal to ZQ. Z is called electrochemical equivalence. So Z here is equal to electrochemical equivalence. It is a constant. It is a constant. All right. Further investigation showed that mass of that substance is equal to molar mass of that substance multiplied by Q over CF. Where C is the charge on the cation. If we compare this formula to this formula, which is mass is equal to ZQ, we will notice that this corresponds to this, and this also corresponds to this. No, this corresponds to this. All right. So as a result of that, the electrochemical equivalent, which is Z, is equal to molar mass over CF. Molar mass over CF. All right. Let's look at one example. Let's look at this question. So our Z is already molar mass over CF, and we have this formula as M is equal to ZQ, and we have Q is equal to NCF. These are the formulas I want to give to you for this Faraday first law of electrolysis. In my second video, we are going to look at another formula entirely, which will talk about the second law of electrolysis. Now, let us solve this problem. What are the formulas? Let us write them again. One, the first formula here, we said Q is equal to NCF. We said M is equal to ZQ, and we said M is equal to MQ over CF, and we also said we also said Z is equal to capital letter M over CF. Don't forget that capital letter M is the molar mass. Now, solving this problem, 24,000 coulombs of electricity are required to discharge a 0.25 mole of potassium from a molten potassium chloride mass. Then the number of coulombs required to discharge 3 moles of lead from molten lead 2 bromide is dash. All right. So we are talking about potassium. It has only one charge. The oxidation state of potassium is usually 1. So as a result of that, we see that Q from this formula, Q is equal to number of moles, which is 0.25, multiplied by C, which is 1. And this is F. We are not given F in this question, but we are given Q. Our Q is 24,000 is 0.25 F. So from here now, F is equal to 24,000 over 0.25. Please, can I have a calculator? Now, so F is equal to 24,000 over 0.25. Now, in this, we have then the number of coulombs required. We are asked to calculate charge now. We are asked to calculate charge. To calculate charge now, I have Q is equal to NCF again, which will give me 3 moles. We are given 3 moles. So N here will be 3 of lead. Lead is 2. The oxidation state of lead is 2. Multiplied by 2. What is the F got here? Multiplied by 24,000 over 0.25. So if I use my calculator, 3 times 2 times 24,000 will give me this, divided by 0.25. I will have my Q is equal to 576,000 coulomb. That is the correct answer for this question. So the correct option here is B. That is for that question. Now let's look at the next question. Let's look at next question. Now for the next question now, we have copper 2 tetraoxosulfate 6 is electrolyzed using platinum electrodes. How many grams of copper are deposited when a current of 0.386 ampere is passed for 50 minutes? From my formula, mass is equal to molar mass multiplied by Q over CF. Alright. Now for this question, we will need to apply our F to be 96,500. So what is the molar mass? We are not given here. What is the molar mass of copper? Well, I hope the molar mass should be given here, but it is not given. So the molar mass of copper should be 63.5. So I have 63.5. Q is equal to IT from our physics, and we are given current here. So multiply by 0.386. Then multiply by time, which is 50 minutes. That will be 50 multiplied by 60 to convert it to seconds. What is the charge on copper? The charge on copper is 2. And what is 1 Faraday? 1 Faraday is 96,500 coulomb. So using my calculator now, I have 63.5 multiplied by 0.386 multiplied by 50 multiplied by 60. That will give me 73,533. 73,533. Alright. So what is 2 times 96,500? 2 times 96,500. That will give me 193,000. 193,000. By dividing this, what do I have? I will have 73,533 divided by 193,000, and that is 0.381. So I have 0.381 gram. So the correct option is D. The little discrepancy here is as a result of whether we are not clear of what the molar mass of copper is, but we are very close. So the correct option is what? Is D. Thank you very much for watching this video. Always remember to subscribe. This video is from Tutopedia Tutorial Center. We are located at Agbowo, very close to University of Ibadan. Thank you so much for listening.